Hey guys, we are back here with the practice of the past papers related to kinetic particle theory, separation techniques, purification techniques, and distillation. All right. So a student uses the apparatus to separate a mixture of three alkanes. Alkanes are the specific compounds which I will teach you, inshallah, in the topic of organic chemistry. Right now, I'm just telling you that alkanes are the compounds which are made up of carbon and hydrogen. Right now, you people can keep this information. Okay, so what is this apparatus for? This apparatus is for fractional distillation. How you people can have an idea, you people can look into this apparatus, and that is called as fractionating column. Here examiner is asking this thing as well, that what is the name of B? It is called as fractional distillation with glass beads. Okay, or this is called as condenser. This A, examiner is asking what is this. This is called A. This is called a mixture flask. This is a specific type of flask. It is called as a round bottom flask. It is also called a boiling flask, and this is considered as mixture flask here. So initially we have taken a mixture of alkanes here. Okay, the technique of fractional distillation is based upon the difference of boiling point, is based upon the physical property of boiling point. So here this is a conical flask and there is a stopper over there. No bung should be there. Bung is also called as stopper. Bung spelling B-U-N-G. Bung or the stopper are the same things. So bung or stopper should not be here right now. And this is called as a receiver flask. Let's solve the questions. There is question number A. Name apparatus A and B. A is called as Liebig condenser. A is called as Liebig condenser. You may write condenser as well. Condenser is an apparatus which is used to shift the vapors of a substance back into the liquid state. Then is the B. What is B? It is called as fractionating column. Okay. Then what about the B question? Identify, a good student can write this thing as well, fractionating column with glass beads. Okay, because glass beads or glass wool, I am writing here for your convenience, it is glass beads or glass wool, or it is called marble chips, which are filled in this fractionating column to increase the surface area of fractionating column, hence to improve the efficiency of fractionating column. So what about the B part? Right now I'm reading this. Identify two errors in the assembled apparatus shown in the diagram. Water inlet and outlet should be opposite. You can see this thing that examiner is drawing water outlet over here and water inlet over here. This is the wrong position of water inlet and outlet. What should be the right position? Water inlet should be anti-gravitational. So water should go inside in the anti-gravitational direction. Why it is so? Because in the anti-gravitational direction, it has to be in contact with the condenser for a longer interval of time. Water will be pumped up with a great force and it has to be in contact with the condenser for a longer interval of time. Okay, there should not be any stopper or a bung in the receiver flask, as the fractions which are coming from this high temperature to the fractionating column to the condenser and finally to the receiver flask are comparatively at a high temperature. For example, what is the boiling point of water? It is 100. It will be turned into the liquid. Let's suppose that the water which is coming over here, collected over here, is like 41 degree temperature, or 41 degrees Celsius temperature, or 42 degrees Celsius temperature. It is comparatively at a higher temperature as compared to the room temperature. So as a result, there might be a pressure development over here. Here we are going to discuss about alkanes. Alkanes can be having a boiling point much lesser than that of water as well. So there is a possibility that a pressure may be developed over there. Okay, due to that pressure, this flask may be burst out. So that's why the receiver flask must not have any bung or a stopper. There must be a bung or a stopper with a thermometer. Sometimes examiner is not drawing a bung or a stopper with a thermometer. So if there will be no bung or a stopper with a thermometer, what will happen? The thermometer will fall down. So please make sure that there must be a thermometer, there must be a bung or a stopper over here, and there must be a bung or a stopper over there, so that the this fractionating column may not fall down into it. Or similarly, if it is not falling down, there will be some escape of the alkanes or the substances from here to the sides, from this sides. Okay, they may get escape. Okay, so water inlet and outlet should be opposite, and there should not be any stopper in the receiver flask. These are the very, very important points. Okay, now they are saying the errors are corrected. Okay, done. The mixture of alkanes is heated in the flask to start the separation. All right, done. Then the boiling points of alkanes are shown. These are the boiling points over there. We can see that there are three types of the alkanes. One of them is octane, nonane, and decane. All of them have boiling points above as compared to water. Okay, so state why the flask is not heated directly on the flame of a Bunsen burner. So mixture is flammable. We should know this thing, that whensoever examiner is saying that something is not carried out on the Bunsen burner or on the direct flame. So why it is so, a student should know. One of the major point is this, that the fractions, the things which we are heated, the substances, the reagents, the chemical reaction which we are going to carry out can catch fire, is flammable. That's why this is not carried out on the direct flame. Then there is another question, state why the flask is not heated with a beaker of boiling water. Here the temperatures, the boiling points of all three are greater than 100 degrees Celsius. In the water bath, the temperature is not increasing not increasing more than 100 degrees Celsius. We know this thing, that water's boiling point is 100 degrees Celsius. So in case of this water bath, the temperature is not increasing than 100 degrees Celsius. Okay, as alkanes have boiling points more than boiling point of water, that is 100 degrees Celsius, and the temperature of the water bath will not exceed 100 degrees Celsius. Name a piece of apparatus that is suitable to heat the flask. Electric heater with a thermostat. Okay, with a controlling thermostat. So for example, if we want that temperature may not exceed 175 degrees Celsius, or for example, if we are separating nonane, and after nonane, when the temperature will be 152 degrees Celsius on the thermometer, it will giving us an evidence that all the nonane is separated as well. And now the only thing left in the mixture flask is decane. So we can set the temperature on the thermostat that it may not exceed from 152 degrees Celsius. So when the temperature will be more than 151, it will just giving us an evidence that all the nonane is separated. So for this type of the mixture, we have to have three flasks. One will be the mixture flask, in which the originally we have taken all that mixture. Decane being the highest in the boiling point will be remain there, whereas we will keep the first receiver flask for octane, and when the temperature will be above 126 degrees Celsius, it will give us an evidence that all the octane is removed. So then we can place an other flask for nonane, and as a result of that, when the temperature will be above the boiling point of nonane, this will giving us an evidence that all the nonane is removed as well. So when the temperature of one fraction, when the temperature of boiling point of one fraction will be over, we will keep another flask for the next fraction. So name the first alkane collected in the conical flask. It will be octane. And what is the explanation which I have just shared with you? Fractional distillation is based upon the boiling point. So the one with the lowest boiling point will be separated first. Okay, so octane will be start collecting first in the mixture flask. State the purpose of apparatus B. So we have seen the B apparatus. It is called fractionating column. Okay, to separate all the alkanes at their boiling point. To separate the alkanes of close boiling points, they are close values. To separate the alkanes at their boiling points, perfect separation. Okay, so this was a question of 9 marks. So a student should try to get 9 out of 9 with high accuracy. And how it can be, it's not very difficult topic. You people can go through that video in which I have taught this whole thing, and then you can answer these questions. Okay, Now there is another question related to the same topic. So substances can be classified as elements, compounds, or mixture. This topic is not particularly part of kinetic particle theory or separation and purification techniques, but let me inform you this as well. What is meant by the term compound? A compound is a chemical combination of two or more than two different type of elements. A compound is a chemical combination of two or more than two different types of elements. Okay. Mixtures can be separated by physical processes. Okay, so we can say by physical processes, they are very clearly saying this. A sequence of physical processes can be used to separate common salt, sodium chloride. The common salt which we are using in our home is sodium chloride, and now all of you should know this thing, that how to write the formula of sodium chloride from a mixture containing sand and common salt only. Give the order and the correct scientific term for the physical processes used to separate the common salt from the mixture. Okay, so number two will be filtration. Okay, what to filtration? Filtration to to separate NaCl solution from sand. Number one, it is solution formation by adding water to NaCl and sand. And number three, evaporation till dryness to get pure NaCl, pure dry NaCl. Okay, so here is X over there. Examiner is asking about the next question. The boiling points of four alcohols A, B, C, D are shown. A student suggested that the apparatus shown could be used to separate the mixture of alcohols. We can see this thing. So there is one thing missing, and that one thing is called as thermometer. We know this thing very clearly, that bulb of the thermometer should be opposite to that of the opening of condenser. There must be a bung over there, because if bung will not be there, the thermometer will fall down. Here is the water inlet, whereas at the top is the water outlet. It is water outlet, and that's it. Okay, so they are asking what is this, so we have to mention the name of the drawing which we have made, thermometer. All right, and this X is called as condenser. Now move to the next part. Okay, so this is a fractionating column along with the glass beads or marble chips or glass wool. Okay, let's see. Apparatus X needs to have cold water flowing through it. Draw an arrow on the diagram to show where the cold water enters apparatus X. Name the apparatus X. It is called condenser. Okay, I have mentioned over there. Okay, part of the fractionating column is missing. This means that this experiment will not work. Draw on the diagram the part of the fractionating column which is missing. Okay, you can see this thing, that fractionating column is there, and it has this glass beads in it as well. We can mention that as well. So it is glass beads. Okay, but what part was missing? It was the top stopper. So that is the stopper which was missing actually, and there should be a stopper or a bung. Okay, so there should be a thermometer over there as well. Explain why, draw on the diagram the part of the fractionating column which is missing, which we have drawn. Explain why the experiment will not work with this part of fractionating column missing. So if this stopper will be remain missing, what will happen? The fractions can go out of the fractionating column, and thermometer will fall down into the fractionating column as well. Suggest why a Bunsen burner is not used to heat the flask. Again, the same answer. The fractions to be separated are flammable. A hot water bath cannot be used to separate alcohol C and D. Explain why. You can see this thing that both C and D have boiling point values greater than that of water's boiling point, that is 100 degrees Celsius. So that's why water bath cannot achieve temperature greater than 100 degrees Celsius. So water bath cannot be used to separate those fractions which have boiling points greater than that of water. All right. So here there is another question. All right. The diagram shows the apparatus used to prepare a dry sample of a gas. Okay. The gas is more dense. It is really very clearly mentioned that it is more dense. So it will go downward. Okay. So there is a burette over there and there is a clamp. This is the clamp of burette which is controlling the flow of the liquid through burette. If clamp is closed, the liquid cannot come out. Okay. And we have mentioned very clearly that this is the delivery tube, the gas delivery tube. Okay. Complete the boxes to name the apparatus. This is called gas jar. We already know this is called delivery tube. This is clamp, although they are not asking, but I'm just letting you know. And this is called burette. Okay. Identify one mistake in the apparatus. The gas will move downward as it is more denser. Okay. So this gas is moving upward. So this is a mistake. So what you should say, that gas jar should be downward. Okay. The gas jar should be downward. Okay. Then what they are saying, suggest a reason why the gas is passed through concentrated sulfuric acid. I have taught you that there are three types of the drawing agents. Drawing agents means those substances which are absorbing the moisture. Drawing agent number one, concentrated H2SO4. And what is the name? Sulfuric acid. Number two is calcium chloride, CaCl2. Number three is calcium oxide. You can see this thing, that how I'm writing the formula and what is the way to write down the thing very exactly. So sulfuric acid is used as a drying agent to absorb the moisture. Okay. So here there is a very important question, and what they are saying here, E numbers identify chemicals which are added to foods. Okay. So there are specific type of compounds which are called as esters. This is not esters, it is esters. Okay. So I will teach you esters inshallah by the end of organic chemistry inshallah. But before that, let me inform you that esters are the specific agents which are used for the flavors in our daily routine, for example vanilla scents, etc. So esters are specifically made by a organic chemistry reaction that we will discuss inshallah. Right now this question is somehow associated with that, and it is a combination of chromatography as well. Let's read. E210 is benzoic acid. E210 means ester 210. 210 is a specific market terminology. How could you show that solution of benzoic acid is weak acid? Right now it is related to the acid, that how we can prove that an acid is a weak acid. But before telling you this process, let me inform you that weak acid has no concern. Definition of weak acid has no concern with kinetic particle theory or with lab apparatus or purification and separation techniques. But I am informing you what is the test for that. So acid will be added, you may say benzoic acid sample will be added to sodium carbonate solution, for example to sodium carbonate solid, or you may say magnesium metal. Low level bubbling, the lesser number of bubbles production will prove this, that benzoic acid is a weaker acid. So if for example any metal, not any metal, let's suppose magnesium or zinc, these are quite reactive metals. We are not supposing silver or gold, they are quite very less reactive metal. We are going to discuss the reactivity of metals soon inshallah. But right now I am informing you that for example we are taking two metals as an example. One of them is zinc and the other of them is magnesium, and we are adding them to a weaker acid. What will happen? Bubbles of hydrogen gas will be formed, but with a very low speed. But for example, if we are adding these metals to a stronger acid, let's suppose HCl, it's a stronger acid, then bubbles of hydrogen gas will start forming, but with a greater speed. So for a stronger acid, the higher number of bubbles can be evident, but for the weaker acid, the lower number of bubbles will be evident. Okay, so E110 is sunset yellow. So E110 is ester 110 and it has a specific market name that is called as sunset yellow. Online, okay, outline a method you could use to show the presence of E110 in a food coloring. You may draw a diagram to help your answer. So here you people should know this thing, that examiner is expecting from you to draw the diagram of paper chromatography. Okay, so this is the level of solvent, depth of solvent, and this is the start line. Whereas this is at the top is solvent front. So here I am mentioning it is solvent front, solvent front, and this is called as start line. Okay, so this is, for example, sunset yellow, and this is food coloring. So this is going to be shifted into three spots, whereas sunset yellow is shifting only in one spot. So we can say this thing that as their spots are coinciding in the distance, we can say this thing that sunset yellow is present in the food coloring. Okay, so this is how we are going to discuss this, and this is what called solvent. Before moving ahead, let me inform you that there must be a lid over there. Okay, please be careful about the lid. Why it is so? Because solvent may evaporate and can affect the results. Okay, so here you are going to say that a paper chromatogram will be taken on which a start line will be marked with the help of a pencil. As it is a food coloring, so it will be soluble in water, so solvent selected will be water. A food coloring spot and the sunset yellow spots are placed on the start line with the help of a dropper, and then this paper is adjusted below that start line in the solvent, and then solvent will start moving up after specific interval of time or after longer interval of time. When experiment is completed, the spots were marked and their distances were noted. It is noted that sunset yellow spot and the food coloring spot are at the same level, which are just telling you that sunset yellow is present in the food coloring. Okay, so this will be the detail about this, and remember this is a 4 mark question, so examiner is asking about the labeled diagram over there, and then an explanation. All right, so I would like to finish this question. Okay, this. Okay, calcium carbonate, CaCO3. From now onward, you people should start making your own collection for the formulas of different type of the compounds along with their names. Calcium carbonate, this is the formula of the marble chips, marble stone. Calcium carbonate, CaCO3, reacts with HCl. Vigorous bubbling is seen due to CO2. A student investigates the rate of the reaction, I mean to say the speed of the reaction, with which speed this reaction is going to finish, using 3 samples of calcium carbonate. Each sample has a different particle size. So one is, for example, the blocks of calcium carbonate, the other is chips of calcium carbonate, and the third is powder. Okay, so for example, this is one size and this is another size, whereas this is the third size. Okay, so in each experiment, the student adds all the calcium carbonate and excess of dilute hydrochloric acid in apparatus E. So what is apparatus E? It is called conical flask. You people can see this thing that it is always used in titration, but here they are performing the experiment and they are using conical flask again. Okay, conical flask. Okay, which variable other than mass is measured in the experiment? Using name the apparatus used to measure this variable. We can see this thing that a gas is forming in this chemical reaction as well. How we know this thing that a gas is forming? Because G stands for gas. These are the state symbols which are written in a chemical equation to tell you that what is the state of a matter. So if it is G, it stands for gas. If it is small l, it stands for water. You can see that with water it is L. If it is S, then it means that it is solid in state. with calcium carbonate, it is S. And if it is AQ, it is aqueous. It means that it is dissolved in water. So what is the variable? Volume of gas. Volume of gas which will be collected. Or here we are going to collect this gas. They are asking about the variable. So this cannot be the answer. Okay. So what is the variable? That can be the temperature. Okay. So we have to keep the temperature constant. Okay. Temperature of reaction should be constant. Okay. And what is the apparatus with which we can keep the temperature of the reaction constant? For example, with the help of a thermometer and a thermostat. So in our surroundings where we are performing this practical, in our surroundings, the temperature should not undergo a change. If temperature will undergo a change, it can definitely affect the speed of a chemical reaction, the rate of a chemical reaction. Okay. Why does mass decreasing? Remember this thing that whenever in any chemical reaction, if a gas is forming, it is just letting you know that mass will be decreased. So whenever a gas is forming, mass is getting decreased. Thank you very much, guys. So we have solved few of the questions in this video as well. I'm going to continue this with other questions for the same chapter first, and then we will pursue towards the next topic. Thank you very much. Take care.